get right to the meat and potatoes, if you will. So a little bit about myself. If you don't know me, I celebrated 34 years yesterday, actually, in the industry. 25 of those years was in a truck. I am a licensed journeyman and all that good stuff. Prior to coming here, I was the Copeland senior technical trainer for Emerson for quite a few years. So I've tore a lot of compressors down, and I used to teach the CO2 transcritical class and what have you. So enough about me. A little bit about us as Chemours. It's not really a household name. Chemours used to be what DuPont was in 2015. So everything DuPont owned, trade name Freon, is now owned by Chemours. And moving forward, when you see this lower GWP refrigerant, you're going to see on our boxes anyways, Opteon. It's the new word for Freon. There'll still be Freon around, but this will be for what we already use, the legacy type stuff. So what's in it for you? How are refrigerants classified as an A2L? What does the A mean? What do the numbers even mean to you and I? Knowing which A2L refrigerants you'll likely encounter in the field and what to expect when working with them. And then saturation temperatures and pressures of A2Ls and what tools are needed. Is a new EPA card needed? And identify A2L refrigerant tanks moving forward. The safety and handling of mildly flammable refrigerants, fundamentals throughout the class, and then we'll have a Q&A. NATE certifications will be issued. You will be able to scan a QR code at the end of this and get credits for this if you need them. So starting off this, I wanted to put this up in front. So moving forward, because of the way the EPA or the AIM Act has wrote this up, a lot of the refrigerants, or at least some of them, will be going away. 404A, for example, Chemours stopped making that this year. It's been banned in Europe for quite some time. California has eliminated it. So the reason I'm telling you all this is retrofitting gas is going to be really important if you're in the refrigeration side. If you're not, then this doesn't pertain to you. Everything in green is a replacement refrigerant for everything above. This is a low and medium temperature, R22, 404A, and you can see how high the GWP is. And this is what everything is going to be based on, the global warming potential. Unlike when we took our EPA cards where it was ozone depletion. This is a new thing, a GWP. So you can see the threshold here for Opteon R449A is 1282 compared to 4000. This is almost a perfect fit. As far as capacity, you lose nothing, and in some cases you actually gain. Now when you look at the blue boxes, this will be the refrigerant moving forward in the new equipment, only designed for A2L refrigerants. So in the case of low and medium temp here, refrigeration, you'll have 454A and 454C. Going to the right, air conditioning and chillers, again, pretty much the same as we had before. You have no drop in refrigerant besides R449A, again, this box over here. And on new equipment, it'll be 454C. Now over here, refrigeration, air conditioning, chillers, if you're using 134A, whether that's in your automobile or medium temp, an exact, and I mean exact drop-in will be 513A, and it is actually owned by Chemours. Even when I was at Copeland, we were talking about this. This is a very good refrigerant. It's the least changed thing on any equipment that I've ever seen. As far as your cars, 1234IF is being used. Again, that's an Opteon or a Chemours product. Over here in the air conditioning, chillers, heat pumps, you'll notice there's no replacement for 410A or R32. The green box is not there at this time, and I don't foresee it happening because of the technical sides of it, trying to get the chemistry right. There will be a drop-in, if you will, or a retrofit for air conditioning. On new equipment, it'll be either Chemours product 454B, and in some cases 454C for chillers. Okay. Now, so what's an HFO? I want to take a little time for you to understand this a little bit, not just it's not just that it's a tree hugging, if you will. It's actually good refrigerant. It's very good capacity, especially on the COP as far as the system as a whole. So we had CFCs, R12. HCFCs, R22. HFCs obviously is what we're moving away from. This is global warming potential. This was ozone depletion. Notice the C up front here. That identifies the chlorine, which we got rid of because of the Montreal Protocol Act and our EPA cards. That we went to HFCs to get rid of that C up front, but now we have a different issue on the global warming potential. So we're going to HFOs, and an HFO is almost exactly, and I mean exactly, like an HFC molecule. The reason I'm sharing this with you, there's nothing really different here the way the refrigerant's going to act. And this is a hydrofluorocarbon also, but it says olefin. And the reason it says olefin is because years ago, if you were to put your hand over one of these C's, that's a carbon atom. And years ago in the labs, they discovered if they bonded, they call it double bonding, two carbon atoms next to each other, it breaks up a lot faster in the atmosphere. So if you put your hand over this C right here, or this C even right here, you would have an HFC molecule. But that's not what I really want to share with you. Here's what I really want to share with you. On the left-hand side, we have 134A, again, an automobile, medium temp, and we have 1234AF, the molecule I just showed you, which is in 454B, by the way, and a lot of other things. This stays in the atmosphere approximately 13 years. This stays in the atmosphere approximately 10 days. When it comes to global warming potential, which we haven't gotten into, the higher this number is, the faster it's on the chopping block. Remember, 404A was approximately 4,000. So actually 134A isn't that high compared to the big world, like 410A is 2,000 or so. But look at this comparison here, less than 4. And if you know anything about refrigerants, even CO2 is 1. So this is pretty good stuff. Breaks up very, very fast. Here's the part I like because of my mechanical side or my service technician side. I've turned more wrenches than I have given webinars. Here's our pressure over here. Here's our temperature. Notice the 134A and the 1234IF running almost like for like until it gets up in the higher pressures, higher temperatures. Now, 1234AF can be used in smaller charges, but it's going to play a big role moving forward in blends. It's already in R449 and 448. And again, like I said, 454B, this is what kept that global warming potential down. So are A2L refrigerants new? They're not. So if you bought a new car in the last 8 years, you more than likely have A2L refrigerants underneath it. A car that's been made in the last 8 years. If you bought a used one, new one, whatever. Every car sold and made in America and most of the world has A2L refrigerant. Again, that's underneath the hood of your car. And that transition was easy for them, and nobody, it wasn't on the national news because they're used to making cars for 100 years, and they put highly, highly flammable solvents underneath the hood of the car, and we don't think anything of it. Gasoline, obviously, night and day compared to A2L refrigerants. A window unit, a PTEC unit, even a dehumidifier or a mobile unit, you more than likely are already around A2L refrigerants. I travel somewhere around 35 weeks a year, somewhere thereabouts or a little over that. There very seldom do I not see R32 on the PTEC unit in my hotel room. Very, very seldom. And the reason for that is most of this, gang, is driven by the Asian market. We don't make a lot of this stuff in the States anymore. So it comes over, and Daikin owns, or let's put it this way, has a lot of skin in the game with R32 as far as helping develop it. Okay. All OEMs, by the way, are going to go with R454B, Chemours product, with the exception of Daikin. Daikin will be going with R32 and anything Daikin owns, Goodman or Amana. So there'll be two different refrigerants out there, but most of it will be 454B. When it gets into mini splits, you're going to see about a 50-50 split. And then when we get up to the larger stuff and chillers, there'll be some divide there. But for the most part, mainstream is going to be 454B. So R32 has been around us. That's an A2L refrigerant already. It's already half of 410A. A little bit about on the government side. I'm not going to spend a lot of time on this because we're kind of past it already, but just to brief you or recap on it. The first step of the AIM Act. The AIM Act is American Efficient Manufacturers Act. And this is just for the United States. Okay, it's not international. This is for the US only. The first step was the CO2 equivalent limitations, which simply means allocation simply means how much we can produce. Now that I'm with Chemours as of about 3 years ago, it affects me, the company I work for. And what that means is how much virgin refrigerant you can produce based on its GWP value. Okay, and I'll get into that just a little bit more as we move along. The second step went into effect in October of 2023. It's referred to as the technology transition rule. To give you an example of what that looks like, this has to do with applications. So if it's a split system or if it's a supermarket, you're going to have different values of the GWP in that refrigerant. To put it in a nutshell, the longer the refrigerant line is, the less choices you'll have. So the more chances for leaks on the refrigerant line, the longer, the bigger the charge, you'll have less choices. So that's why you see a lot of people in supermarkets right now, some anyways, going to like CO2 because it has the equivalent of 1. Okay. And the third one, it's final now, but it's still in litigation. It originally was shot down by the Supreme Court, but the third one talks about refrigerant management programs. And at a very high level, some of the things they had in there documented that got shot down by the Supreme Court was returnable or refillable refrigerant tanks, kind of like our propane tanks. They do that in Canada already, if you didn't know. There was talk of putting QR codes on those tanks and documenting from the wholesale side where they were going. Also, there was verbiage in there about using reclaimed refrigerant by 2028, January 1st, 10%, all OEMs would have to be 10% of reclaimed refrigerant inside new equipment. That's all OEMs, whether it's refrigeration, air conditioning, whatever it is. And like I said, that got shot down, but it came back up this year and it passed, but they removed the refillable tanks and the QR codes. But there's still some verbiage in there about, there's still verbiage in there as far as the reclamation. Reclamation is going to become huge. If you don't already know that, if you're not recovering refrigerant, I don't want to stand up here and act how great thou art, but I'm telling you right now, it's going to be like gold. I've sat on many panels with some of the big shots from other recovery refrigerant management programs like Hudson and what have you, and they're telling hundreds of people in front of me at ACA, any presentation I've done with them, you bring your refrigerant to us, we will buy it, even if it's mixed. Now they want it just like we used to, as single as best we can. But what they're telling these groups is they have the technology now. They're referring to it as digital, but they can remove each one of those refrigerants. Let's say there's 4 of them in there, whether there's dirty oil or dyes, they can go in there and separate that and bring it back to virgin. This is going to be a big deal because this part right here, the first step, is reducing new refrigerant on virgin refrigerant. So it's getting penalized for virgin refrigerant. So when you use reclaimed refrigerant, it's already been penalized once. It won't be penalized again. So keep that in mind. So going over the 3 steps, first of all, we had the allocations, the step down, all right? In 2021 was baseline. That's 100%. We went down 10% in 2022. We went down another 30% January 1st of 2024. In 2029, we'll go down another 30%. So as we keep going down, okay, we'll have less and less virgin refrigerant, all right? Just like we don't buy virgin R22 anymore, it'll be the same concept. It's a step down approach. This is not a phase out, but a phase down, but you can see it's aggressive in area. The goal is to be down to 15% by 2036. So they're reducing 85%. And this is based on the global warming potential. It's not by pounds. It's not any one refrigerant. It's not just 410A. It's all things with HFCs in them. It's not even all refrigerants. So there's HFCs in solvents. There's HFCs in foam blowing agents, fire extinguishers, inhalers, all kinds of things. So you got to kind of pick what you want to produce. Chemours and our competitors have to pick. The higher the GWP, the faster it's on the chopping block, because that's going to take up all your allocations. So moving forward, the technology transition rule, again, this is applications. Just the movement from 410A alone to 454B is going to be a 78% reduction just in that part of our market in our industry, just from comfort cooling alone. Okay. And then lastly, that third step of the AIM Act, the Refrigerant Management Act. And you're probably wondering, hey, Don, by 2036, we're going to be down to 15%. How can we possibly run the industry without crippling it and be down to 15% when in 2021 we were at 100% and just keeping up with it? Well, if you remember the GWP value of 1234IF, all the refrigerants moving forward are going to have a very low GWP. So not only will you be able to make as much, but you'll actually be able to make more. Just think of it like this. If you have two 5-gallon buckets and a high GWP refrigerant is, let's say, the size of a tennis ball, and low GWP refrigerant is the size of golf balls, basically that's what this is telling you. I can put a lot more golf balls in my bucket than I can tennis balls. And that's the way manufacturers are going to look at it. Again, that first step is based on virgin, first-time refrigerant, or first-time HFC, which is refrigerants also. And so it's virgin. Okay, that's why this reclamation is going to become huge, because by the time we get down here, just like R22 is today, you don't buy virgin R22 in the US. If you are, it's illegal. Okay, this is what's going to make it up for it. All right. Again, you're going to see a lot of people moving into the market. We already see it right now. Companies that already do this for a living are getting bigger. Companies that aren't in this market are moving into it. And the reason for this is you can produce as much recovered refrigerant as you want, okay, because it's already been penalized once. So that's going to be a biggest move I've ever seen in my career as far as recovering refrigerant. Now, the technology transition rule, just a little bit more down in the weeds. First, I'm going to start at the bottom. Its compliance is determined by its application, as I talked about earlier, whether it's a split system or a rack or whatever. It's also based on its GWP limit, how much GWP, global warming potential, and then the effective date. Moving forward, as we already know, we're in the comfort cooling stages right now. They decided to unveil the comfort cooling first, and then refrigeration would come secondly. So that equipment's not actually being produced yet, but air conditioning or comfort cooling is. So going to the left here, as of January 1st of 2025, residential AC will only, the cap will be 700 GWP and no more than that. So there's only two refrigerants out there that qualify for that, and that's R32 and R454B. Ice rinks will have no more than 700 GWP. Comfort cooling chillers is 700 GWP. And again, that goes into effect January 1st of 2025. In other words, no equipment, comfort cooling equipment in these categories can be made after the first of this year. Okay, and you're already starting to see that. Most OEMs with comfort cooling have already ran out of equipment, and they're already selling 454B. I took a poll yesterday on a live webinar I did for our wholesalers, and it said 70% of the people at their branches are already selling 454B equipment. January 1st of 2026, you're going to see remote condensing units and VRF systems, okay? Now, when it comes to remote condensing units, remember when I said it's going to depend on how much charge is in it or how long the line set is? So if it's over 200 pounds, it has to have a GWP of less than 150 or below, okay? That's why you saw the 454C, okay? Condensing units less than 200 pounds, it has to be less than 300. So the smaller the charge, the higher GWP. So that's why we have a 454C and a 454A. A, B, and C all have the same components that make up that refrigerant. It's R32 and 1234F. It just depends on the ratio or the percentage of each on how low you want to go, and that determines the GWP also, okay? Now moving to the right, January 1st of 2027, the last part of our industry to come on board will be the supermarkets and air conditioning for data centers. And that refrigerant will be anything over 200 pounds will be identically what it was with condensers, less than 150, 454C, and supermarkets, or pardon me, over 454A or C, pardon me, at less than 200, 454C. The only reason 454C was invented by Chemours was simply because when the EPA wrote this up, we had to find an application that would suit it. Okay. So that's it for the second rule. To bring it to a head, basically what I said earlier, starting January 1st, 2025, we talked about that. That will go into effect. It's already in effect. Now, originally when this was wrote up, there was no sell-through date. There was no installation date. So before it got, before ACA, Hardy, and a couple other organizations that defend us in our industry, before they took the EPA to court and won in the Supreme Court, this was actually stop manufacturing the equipment and also no installation, no sell-through date. Well, there was a lot of pushback, obviously. They didn't understand the industry. So they extended that to be able to install, let's say, 410A equipment until 2026 and also a sell-through date, okay? Now, when they did this, they did it for commercial stuff and air conditioning and residential. So in other words, P-TECH AC, P-TECH heat pump, residential packages like commercial package units, and the same thing. This was all supposed to stop at January 1st, 2025. Well, once they understood our industry, because I've done many of strip malls like you probably have, I've slung a lot of rooftop units up on buildings throughout my career, and those things don't just fly off the shelf. It's somebody like me or you that comes into the branch and hands them a blueprint and said, I need 10 of these or 5 of these. Well, they didn't understand that. So once they understood that, they extended that to January 1st of 2028 for the sell-through dates and installation dates. So to do the Don Gillis version here, if it comes from the factory, and we're called tin knockers, and a Sparky can run electric to it and it starts up, that's 2028. If you can plug it in, a P-TECH unit, heat pump, that's 2028. So if you can run electric to it out of the factory and it starts up, and all you had to do was run a little power to it, that's 2028. If you have to erect it in any way, that's going to be 2026. All right. And then again, at the end, we'll see medium low temperatures will go into effect January 1st of 2027. Now, I used to dive into this because of my travel, extensive travel throughout the nation and North America. I used to have to look up all the different cities and municipalities. Thank goodness I don't have to do that anymore. AHRI about 7 months ago came up with this website. You can easily just put AHRI A2L building codes in there on the Google machine. It'll come right up for you. Or you can go to this link here. But what you'll see, and I keep this on my phone, by the way, I downloaded it on my phone so I can send this PDF to people all the time. So what a person can do now at any level, installer, service technician, project managers, decision makers, can pull this up and touch on the state that you're working in at that time. It'll highlight that state, and the drop down will tell you everything in real time where they're at with AC codes, state codes, refrigeration codes, and warehousing codes, and all those kind of things. UL, ASHRAE, even the fire department, what they're calling to. All of them see all the same color here. All of them are pretty much the same, but not always. A year ago, this map was half full, and it was very difficult for me to tell them what was going on in their area. I'd have to look it up before as I was flying there. But it all got approved in some way, shape, or form. It's either approved in legislation for the whole state, or some states actually already have it in their code books. But some code books revolve, like I'm licensed under the IMC, International Mechanical Codes. Some of those code books don't update for like every 4 years or so. So some of them are already in the code books and some of them are not, but they've all been approved in all 50 states. So refrigeration classification, how does it get classified? It's done by ASHRAE. ASHRAE makes a decision whether it's flammable or non-flammable, and then if it is flammable, how flammable it is. But before it gets to ASHRAE, it's done by a third party. It's the American Society for Testing of Materials, ASTM. and they test it, an unbiased third party, and then they send it to ASHRAE, and then ASHRAE decides whether it's flammable or not flammable. Okay, so obviously Chemours has these testing facilities at our headquarters, just like Copeland had the testing facilities here in Sydney, Ohio, where I live near at the Copeland plant, because obviously we don't want to see egg on our face, so we test it to make sure it's going to pass UL before we send it in, or any of the ASHRAE standards. Okay, so first and foremost, there is no propane in A2L refrigerants, none whatsoever. And I'll show you what's in there and why I think that people think there's propane in there. It's not even close. Before A2L refrigerants, new kid on the block, if you will, there was one non-flammable, let's say 410A as an example. There was two flammable, example would be 152A, and then three highly flammable, and that would be like your propanes and your butanes. If you're not familiar with propane in refrigeration, it's very commonly used. You're only allowed 150 grams in the compressor, in the system itself. That's maximum. That's like 5.2 ounces because of its flammability. The trick with flammable or propane refrigerant R290 is, if you don't know, it has no stench. So it's the same flammability as we use out on our gas grills, or if you convert furnaces over thousands of them like I have through the years, it doesn't have any smell. And that's a whole different animal. That's why instructors like myself get a little frustrated when people compare it to all flammable refrigerants are the same. It's night and day. And then you have the new kid on the block. And this would be, examples would be like R32, 454B, and 1234IF. The difference is here, if we had an imaginary line right here, everything to the right of it, 2 and 3, the burning velocity is greater than 10 centimeters per second. Everything left of the line, 2L down to 1, is less than 10 centimeters per second. And when it comes to 454B, it's not even close. It's like 5.2 centimeters per second, which is like 3 inches. Most of us can walk that fast. I'm not trying to play it down, but my goal at the first part of any presentation I do is to remove the fear mongering. Because when I first started teaching this 4 years ago, that was the big craze. Everybody was scared that this was going to blow all up on them. It's already out there. Don't buy into these YouTube channels you see where the mini split's blown up. That's not A2L refrigerants. Okay. So just moving forward, just know that. All right. Here's a picture of a graph on AHRI's website, and you increase the flammability, you go up higher in numbers. The number part of this is the flammability. The letter is the toxicity. So low toxicity and toxic. So for example, this would have been ammonia. We've been using ammonia since the turn of the century. It was one of the first refrigerants that we used in industrial refrigeration. The problem is it was toxic and it was flammable. Well, when we slip this new category in here, this new classification that has been around less than 9 years on the face of the earth now, and very new to the US, when the ammonia folks saw this 2L classification, they said, hey, if that's a 2L, then we're a 2L. And actually ammonia now is classified a B2L. So that's how new this classification is to us, especially the US. We're a little bit behind Asia and Europe. They've been using them for quite some time. So what does it look like? When they test this stuff, they put just like we learned in HVAC 101, you need 3 things. You need some sign of ignition, you need air, and then you need some concentration mixture to make this ignite. So that's what they do at the labs. I've seen it done many a times up at headquarters. The folks with the lab coats are sitting outside these chambers on their computers. They're adding just enough air, just enough refrigerant, and then they hit this electrode after it's mixed for about 15 seconds or so. If it stays inside this V, or this 90 degrees, it is classified as non-flammable. There's a formula they use, and they've used for years, for the flammability testing. And it's a lot of numbers and a lot of calculations. And honestly, I tried to memorize it, but it was pretty in depth. So just know that this is the goalpost. They're not moving the goalpost. Stays inside this V, it's non-flammable. For example, this is 410A. It stayed inside the V. This is what we're used to. This is the world we lived in all our life inside this 90, okay? Classified as an A1, non-toxic or low toxicity, 1, non-flammable. When they tested A2Ls, this is what they saw. Actual photo with the lights out. This is a digital camera at their labs, not ours. And it just broke that line. Now, again, I'm not trying to play this down because there's going to be different procedures that used to be good practice that's now going to be required by ASHRAE and UL. But now they're scratching their head because they've never had a refrigerant this close to this. But they're trying to stay below the GWP for the EPA. They have to do that. So in order to do that, this becomes mildly flammable. Therefore, we have to have a new classification. To give you an example on the flammable refrigerants, like the A2s, that would be around the 9 and 3 o'clock position if I had a picture of that, which I don't. This, my friends, is what propane looks like. So again, night and day. This is a much more exciting day at the lab, I can assure you. Okay, but it's completely different to A2Ls, night and day. When I see webinars done on A3s and A2Ls and they put it all in one bucket, it frustrates me because I think it's a little misleading. It's not, all flammable refrigerants are not equal at all. They're not even close. There's a reason there's only allowed 150 grams of propane or R290 in a refrigerant system right now. So what did they do? If we didn't add propane, what did they do? So 410A, GWP 2088. 50% of GWP is already an A2L refrigerant, R32. It's in the P-TEC units, what we talked about earlier, and 50% of it's R125. And if you know mechanical stuff, compressors, I know it fairly well. I could tear a compressor down and tell you each part pretty much in my sleep. I've tore thousands of them apart. 50% of it's R125. And R125, what it does, because R32 by itself runs hot. Okay, it's a higher pressure, it runs warm by itself. So this keeps the discharge line cool, leaving the compressor about 6 inches out, but it also is found in every fire extinguisher, almost every fire extinguisher made out there today. And the way it works is R125 in the fire extinguishers, when it's exposed to air, it sucks the oxygen out of the air, making it non-flammable. So we're not really adding anything that's flammable. We're removing the fire extinguisher with 454B. 454B now is 466 GWP, a huge drop. Remember, we had to be under 700. What did they do? They actually bumped up the R32 to 68.9 and circled back around with that refrigerant that's already underneath the hood of your car. Remember, I said by itself on large charge systems, the 1234F cannot hold the capacity. It doesn't have enough for large charge systems, but it's a great blend to add into things to bring the GWP down. So most of what we dropped, the GWP, the stuff that the EPA doesn't like, the global warming potential, was the chemical R125, which kept the discharge line cool and kept it from being flammable. And you already saw the flame comparison of A2Ls and A1s. So you have to make everybody happy. You have to keep it down low GWP. You have to make sure it's non-flammable, and you have to make sure that it does the work. Does the work is first and foremost. Does it do the capacity? So these are some items that third parties have put together, not Chemours, of things that we know that are flammable. And the substance are over here to the left, and it's done in millijoules, or known by MIE, which means minimum ignition energy, which simply says how much strike or spark does it take to light? Does it take a blowtorch, or does it take a lighter itself? And when you look at it, the higher the number, the less flammable it is. So methane, for example, is 0.47. Propane, highly flammable, 0.25. 454B, somewhere around 300. Gasoline, even more flammable, 0.20. And then diesel fuel, 20. Here back again to the gasoline, you know, we put the A2L refrigerants underneath the hood of the car. We got baby seats in the back seat and all kinds of things running around with our family. We don't think anything of it for 8 years now, all over the world. You know, no one's made a big deal out of it because we've been putting gasoline in these cars for years, which is much more flammable than 1234F. Some of the things they've tested out in the field, not Chemours, but third parties, and this is many of them, These are the things that they've tested out on the job sites and in plexiglass square boxes by adding air and the concentration and then trying to ignite it. These are some of the items: cigarette insertions, light switches, cordless drills, a friction spark, a hair dryer, toaster, hot plate insertion. Now, some of this stuff obviously you won't find on a job site, but you will find it in a home in a ducted system. So if there was a leak and it blew through the home, you can see that none of these things will ignite A2L refrigerants. When the blower comes on, it lessens the concentration, therefore it becomes less flammable. So what does it look like Opteon 454B compared to 410A? Well, it's very similar. How similar? Pressure temperature profiles, you can see right on the scale here, almost identical. Similar thermodynamic properties, almost exact. Similar material compatibility. What I mean by that is we already know 32's in system. We already know 1234IF's in systems. We know it's going to play well with others. It's not going to eat the copper, the aluminum, the windings on the motor of the compressor or anything like that. It is the exact POE oil, that's POE 32 from 410A to 454B. Now, when it comes to R32, that's going to be a different number because, again, it runs warmer, so you're going to need a higher viscosity oil. As far as the system itself, it's still a DX system. In other words, it's still using a TXV. It still acts like a duck, walks like a duck, talks like a duck. You're not going to see any different except the component of the leak detection at the very minimum in any system. And that's all it is. It's still going to act the same way. The pressures are almost going to be identical, as you can see to the right here. This is our PT chart, pressure, temperature, right? And you can see how it runs. How are they different? Lower GWP, again, A1 is considered a non-flammable but will combust, and A2Ls. That L, by the way, if you ever taken a test or you'd like to know, if you're one of those people like my wife says I am with a bunch of useless information, the L, instead of making that a 1.5 classification, they made it an A2L. The L stands for the velocity or the speed at which it travels. Remember, I said 5.2 or somewhere thereabouts. This is what the L stands for. It doesn't stand for combustion. It doesn't stand for the MIE. It stands for the velocity or the speed at which it travels. That's what it stands for. So when I took I made all these PowerPoints, and before I came to Chemours, I wasn't great at PowerPoints. I was better turning at wrenches than I am at PowerPoints. But I wanted a visual here for you to see. And so I took a screenshot of this PT chart, this digital PT chart of app. I love apps. And I chose 454B. And from my experience in comfort cooling, not always, but a lot of times you'll see the saturation temperature on the A coil or the evaporator coil will be somewhere between 40-45. Not always, but usually. So I chose 119, and the reason I chose 119 on the low side was because I wanted to compare all three of these refrigerants. I want to be very transparent at what that looks like. So at 119, 410A in the same application, the suction saturation temperature would be 40.3. 454B would be somewhere around 45.5. And R32 is 39.2. This is where R32 really shines on the capacity side of things. So when it comes to capacity, again, like I said, 410A, 160, 155 on 454B, which works out to approximately 2% less capacity when you break it down. And then 174, you actually gain some capacity. But if you know COP, and this is the most important number on here, I'm not pulling your legs. If you've designed systems or been around, you know, me working for years at Emerson and sitting in all those meetings every Monday morning with the application engineers, everything is based around COP. It's the most important number that they focus on when they're designing any equipment. And COP, coefficient of performance, big fancy words there, simply means how much capacity you're getting out of your evaporator compared to how much energy you're using on the compressor or the system as a whole. It's the combination or the formula of both. Okay, so the higher that number is, the higher the efficiency system is. 3.58, 3.68, and then 3.65. This is where 454B really, really shines on the system as a whole. And this is why all OEMs, with the exception of Daikin, have chose 454B in my opinion. Now, when it comes to the basic stuff, suction pressures, if you're seeing 130 on 410A, you'll see 117 on 454B and 133 on R32. High side, 419, 395, 430. When it comes to the discharge temperature, you want to stay focused on this, because if you've ever seen any of my videos, and I've got thousands out there on YouTube and recorded places on podcasts, you always hear me say 225, stay alive. We never want our discharge temperature 6 inches out for compressor to ever be higher than 225 unless it's got some kind of vapor or liquid injection, okay? So if you have it close to 225 or over 225, you are literally burning that compressor up. So 410A, 167. Remember, we removed that R125 from the 410A. Now we're 10 degrees higher. R32 straight up, that's going to run a little warmer. The viscosity or the POE oil for these two is POE 32. This will be POE 46 because it runs a little warmer, okay? And if you want to know where that 225 derives from, over the years, many, many years back before there were smartphones and computers, the guys at Copeland and their competitors in their lab coats realized that by failing compressors that we lose somewhere between 50 to 75 degrees Fahrenheit from the hottest point of any compressor. Now, this doesn't have to do with refrigerant, and it doesn't have to do with the style of the compressor. It has to do with oil. So the fact that we can't put a temperature probe inside the compressor, we assume the worst scenario, and that's 75 degrees. When you take that 75 degrees and add it to 225, you get the magical number 300. And at 300 degrees, they discovered years ago, that's where we start to lose our lubricity inside the compressor, which causes friction. And again, the number one reason compressors fail is overheat. And it's not even close. Liquid flood back, flooded starts, not even close. Okay. So that's the importance of the 225. What's not changing? You will not be required to take a new EPA card. If you've already have an EPA card, you are grandfathered in. This is almost like for like, identical to 410A. I remember being called to the shop the morning they introduced the 410A to us. We took a little test, got a certificate. It wasn't even had anything to do with our EPA. It wasn't recognized by the EPA. It was just something wholesalers were doing at the time because we hadn't experienced those pressures. I remember leaving the shop that morning, going out, loading our trucks up, and me looking down everybody's van, and we're all looking at each other, drinking our coffee and smoking cigarettes, going, I'm not putting that crap in our truck. Those pressures were very new to us. It was almost a little frightening, if you will, from R22 to 410A. Personally, and I've been quoted in Contractor Magazine and other places, I feel that this transition we're doing right now is going to be a lot easier than we saw with 410A. That's just my personal opinion. We're already used to the pressures. In fact, in some cases, they're going to be lower. And when you understand the flammability, how close it resembles what we're using now, honestly, the burden's really going to be on the manufacturer of the equipment, putting the sensor in there. And I look at those sensors no different than I do a high limit switch or a pressure switch. It's another safety switch. If it wasn't leaking refrigerant before, it's not going to leak refrigerant now. As far as our trucks, it is the same as it was before. There's literally nothing changing inside your trucks. And I'll get a little more in depth in that later, including a Class B fire extinguisher on your truck. So that's not changing, even though the flammability. And by the way, I just pulled this off the internet and made this slide, but if your van looks like that, God bless you, okay? Because mine never did. All right. And just, not to beat a dead horse here, but again, it's still the same DX system, okay? We're going to drop the pressure here because we know the second law of thermodynamics tells us what? High pressure goes to low pressure, hot goes to cold, and if you're into IAQ, wet goes to dry. So we're dropping the pressure on that theory, which drops the temperature, which wants our load to pick this up, a saturation, let's say it's 75% liquid, 50% liquid, 25% liquid. The goal is to be all superheat so we don't hear crunchy noises in the compressor. We're moving this by primarily liquid because liquid, we know, as our first year in HVAC 101, liquid transfers heat much better than vapor does. I can stay outside for 24 hours in 60-degree air and survive. But in 60-degree water, 24 hours, you cannot do it. It'll suck the heat right out of you. So it picks up that heat, as we all know, hence the reason we call it superheat, moves it to this vapor on down the line. As it's moving down there, it's getting higher superheat. So when the designer of the equipment calls in and says, what's your superheat on tech support, they're asking for the system as a whole to make sure that TXV is matching the load or the capacity. Down here, Copeland and their competitors, if they're asking for superheat, they're asking for superheat. Here, nothing will change from A2Ls. That's considered total superheat. The first job of this suction refrigerant, if you don't know, if you've never tore open a scroll compressor, is to cool the motor of the compressor. 99.9% of the compressors made out there are refrigerant cooled. It picks up that heat and moves it along. If you see the weld spot on a scroll compressor, right about that area is where it changed from low pressure to high pressure. It gets into the scroll set itself, could be reciprocating, could be scroll type. The moral of the story is what they found years ago was the scientist is when they compress those molecules, they move faster, which raises the temperature, raises the heat, and therefore makes this whole thing work. We're raising the pressure, we're lowering the pressure. We're raising this pressure up, just like we did before. There's going to be no different, so we can reject it outside in ambient air. Come down back to our liquid line, condense it, and this is the system. It's always going to be this way. Nothing's changing. I wish there was more to tell you about it, but there's no more bells and whistles, again, except that sensor that's going to be on there. So there's no fear here whatsoever. All right. When it comes to A2L installations, best practices, moving forward, A2L refrigerants will only be used in new equipment. They are not to be used in existing A1 systems. No matter what I showed you as far as how close the pressure temperatures are or the POE oil, do not use them in an existing system. They're not designed for it as far as the sensors. It's against the law. You are taking a big risk on your liability. Not to mention, even if it's off 10 pounds or 5 pounds on the pressures, that TXV for that 410A system is designed for that system. That pressure drop will be different, even so slightly, and it's going to make the system inefficient and wear down the compressor much, much quicker. Installing or servicing A2L, safety first. Read the OEM equipment manual. That's the only reason I'm here today, because I was the young kid on the job site that they asked, read this manual, back before we had smartphones. Okay, so read the manual. Follow lockout tagout procedures. This is right off the AHRI Safety and Handling Guidebook that they put out for A2Ls. So this is taken right off their website. Verify no voltage is present, ensure area is well ventilated, and then evaluate the work area. So far, have you seen anything different than we use today? No. And when I talk about evaluate the work area, I'm referring to ignition sources, flammable vapors, confined spaces, clear exit points. At this time, it's not required, but it's recommended in UL-240 that they want a 10-foot work perimeter, similar to what you see on utility companies out there when they got things with orange cones and yellow tape roped off on the corner when they're working. That is required by the state. This is not required at this time, but they recommend a 10-foot work area. Check it out for all these things possible, okay? Actually, these are things we already should be doing when we're on commercial job sites. If you haven't, I have, I'll admit you. Our companies have been shut down a couple times that I worked for by OSHA on job sites. They're looking for cords that are spliced or anything that looks like trouble, water, standing water, anything like that. So this is what this is right now. It's a 10-foot recommended. You're going to have to police yourself just like before. Pressure test. Moving forward, the components, the same thing we always have done. Go to manufacturer's specification, whatever it says on the data plate. Obviously, we're going to test the high and low sides. The difference is, for me anyways, in my area, except with gas lines, this is going to, you're pressurizing it now, you have to hold it for 60 minutes or 1 hour. And then you have to document that. That's something new. And when I talk about something new, that's in the code books moving forward. That 15, ASHRAE 15 is for commercial, 15.2 is residential. They mirror each other almost exactly like, okay, like for like. There's a couple of things that are changed on the commercial side, but very, very little. But both of them state you have to hold that for 60 minutes and you have to document it on the job site. And obviously never exceed the manufacturer recommendations. The system shall show no loss of pressure in the measuring device during the test. And if the OEM specified pressure should drop, perform a leak test as always. Record that pressure, date it, and on the equipment label, that is by UL 2-40. UL is the safety of the equipment. What they say on that equipment is inside that door or in that manual, that is required by UL. If you don't do it, then you're gambling. ASHRAE is the safety of how it's installed. That's you and I, okay? Equipment safety, installation safety, all right? Will we need to change line set? So what is changing? The easy answer is no, but it has to be the same size as the new equipment coming in, obviously. So if it was sized wrong before, it's going to be resized wrong again. So if it's calling for a 3/4 inch, 3/8 line set, and that's what the new equipment's called for, then you can use the existing line set. You have to clean it up the same way you did before. I'm not advocating any way. I personally like old school, just nitrogen, but I would be lying to you as a service manager for 8.5 years if I didn't tell you I bought RX11 for our service trucks, for my service technicians. So if you're doing it that way, or you're using nitrogen, or you're using the one that I really like now, the real cool one that I saw at AHR, those little guns that push the corks down them that sweep it real quick, those are pretty cool. So nothing's changing on far as how you're cleaning your line sets. The difference here is when you pressurize a line set, when you assemble it, erect it all up on the new equipment, you have to pressurize it and leave it for 60 minutes. Some of the things that are changing, I'm only going to highlight the stuff in green and red. Most of this is common sense. I know it is. But purge circuit with inert gas. Now, what they're saying here isn't when you're brazing. That's to remove oxidation. This has always been good practice when you open up any refrigerant line set to blow nitrogen through there, purge it, to get rid of the residual refrigerant. Remember the picture I showed you of A1 refrigerant being flammable inside that 90? That little flicker or candle looking flame we see when we get our torch too close to line, that's residual refrigerant of 410A or whatever refrigerant is an A1 classification. That will now be required, and you'll check off on that. Moving forward, you have to evacuate the circuit. Personally, I've never not used a vacuum pump, but I guess they're out there. That's always been best practice. We pull down to 500 microns or less, preferably less. That is now going to be required, and that will be documented also. When we leak test, again, always been best practice. I wouldn't be able to sleep at night if I didn't pressurize my line set after I brazed it together. That is now required. Again, 60 minutes is the magical number they want you to hold that for, and then document that. Now, one would think, and I say this in class all the time because I think just in 2023 alone, I was in front of 6,400 people, in-person trainings. I calculated my totals for the year, and I commonly say, I don't know who's going to police this. Just know that this is going to be the law. This is going to be the required in our industry, okay? It's kind of like when we used to say, who's going to catch me venting refrigerant? The EPA police? I don't know. But the way technology is moving today with QR codes and those kind of things, I have everything inspected in the building department that I work under. I'm licensed in Fort Wayne, even though I'm a Buckeye. I'm just over the state line. I commuted for years in Fort Wayne, where my oldest son is actually a contractor too, and has been passed his master's and has his own business for about 8 years now. So I don't know who's going to catch you doing it, but God forbid if something should happen, a fire marshal has to come out and they detect it was a leak somewhere, and they don't see any documentation. Katie, bar the door. You've got to have some questions to answer. Something new that's coming up now that's not new to me under the IMC or International Mechanical Codes. We've always used what I call striker plates. Some people call them nail guards. Some people call them shield plates. All over the nation, I hear them called different things. On new installations, if that line set is I actually copied and pasted this right out of ASHRAE 15.2, by the way, this is a paragraph. If it's within 1.5 inches from the wall before they put the drywall up, you have to put a striker plate or a nail guard in here. And that nail guard is usually around eighth inch thick. It actually specifies These are sold commonly in wholesalers. Plumbers use them all the time for drain lines and water lines. They're very, very common. So to me, it's not anything new personally. But again, just so you know, in ASHRAE 15 and 15.2, if you're within 1.5 inches of a line set inside a wall from the wall, you have to use a striker plate moving forward, okay? As far as compressor stuff, there is changes to the components inside. So you'll have 3 different models, unfortunately. You'll have a 410A model, classified as an A1, business as usual. You'll have a 454 model, classified as A2L. They had to change some components in there. On the scroll setting, this is the bottom scroll. We call it the orbiting scroll. Here's the bearings. They saw some wear in there from adding the HFO blend in there that they didn't like. To put it, to give you an example, and I've worked with Copeland for years, and I still do training with them all the time, some of my past coworkers and friends. And what they told me is any engineering department can simulate 10 years or 20 years or 30 years. And how they do that, they can do it in like 2 weeks or a month. What they do is they add speed or weight, or they make it really cold or really hot. There's all kinds of things that they can calculate in a computer to mimic what 10 years would look like. And when they did that test, let's say 4 weeks long, to mimic 10 years, they saw some wear that they didn't like prematurely on some of the old compressors or the 410A compressors. So they did change some of the material on some of the compressors, just so you know that, all right? Nothing to do with really compressors, A2Ls, but this is going back to that fact that I wanted to share with you. I think it's important. My goal is, I just turned 62. I celebrated 34 years in the industry yesterday. I'm a lot closer to the end of my career than I am the beginning of my career. And my goal in life is to give back. I teach a lot of students at night. I try to help give back. I'm very proud that my son became a contractor. So this is really outside. Think of it as a bonus, if you will. But if you're already gauging up to a piece of equipment and you want to know how to calculate compression ratio, I hate when people make things too complicated. People, engineers, they hire technicians. They don't want to share knowledge with you because they fear that they're not as valuable. So here's how simple it is. If you look at your gauge pressure, let's say, for example, high temperature compression ratio is around 3-to-1. Medium temperature is 5-to-1. Low temperature is 10-to-1. The farther these numbers are apart, the harder that compressor is working. So the low temperature freezers, minus 35, minus 40, those are workhorses, okay? So the farther those numbers are. Basically what this is telling you is either my head pressure's high or my suction pressure's low, or both, okay? And the farther those numbers get apart, it causes extreme heat, which is the #1 cause of compressor failure, okay? High compression ratio is the #1 reason for high heat, by the way. So what you're going to do is you're going to add your gauge pressure to your gauge pressure, whatever your gauge pressure says on the low side and the high side. You're going to add atmospheric pressure, standard. And for the sake of not arguing, we're not in Denver, Colorado all the time. We're going to say it's 14.7. Now I'm going to add 0.3 for easy math. So add 0.3 to 14.7. So in other words, we're adding 15 to whatever your gauges are, low and high side. And when I calculated that for 454B, let's say we have a discharge line of the side, the gauge pressure. The high side is 428, the low side is 120. We add our 15 atmospheric pressure. It turns it to absolute from gauge pressure, which we don't necessarily need to know that. I don't want to muddy the water here. Just know that now we got 443 over 135. You have to add the 15 or this formula will not work. We then divide the 135 into 443, the low end of the high side, and we get the compression ratio of 3.28, okay? Whatever you get here, put in front of 1. Whether it's 7, 6, 10, whatever, always put it in front of 1. So if you're going up on an air conditioning system and you're already gauged up, I'm not telling you to gauge up if you don't have to, but if you're already gauged up, just add 15 to your gauges and you know exactly. What's really cool about this is now you've told yourself a lot about the compressor. It's almost like it's plexiglass. We're kind of like doctors, but our patients can't talk to us, right? So now if you know what it looks like entering the compressor, and you know 225 stay alive on the backside of the compressor, you've just told yourself a lot about that system. I mean, it's good stuff. Okay, so if you see 10-to-1 compression ratio in air conditioning, I can assure you're not going to see 225 degrees on the discharge line. So just a fun fact there for you. A2L repairing, servicing, or replacing equipment. Of course, we're going to recover, use proper PPE, lockout, tag out. The recovery tanks will have a red stripe run on them, and they also have left-handed threads. The last I heard a month or so ago, there was a shortage of these tanks. They didn't get out in front of it fast enough. They didn't realize R32 or Daikin was selling equipment Q4 of last year. So what they're asking people to do now is, it's the same material, same thickness of the metal on the tanks, same pressures. What they're asking you to do, if these tanks aren't available, is to put the refrigerant of A2L refrigerants in a regular tank, mark it as so, and then put a red mark or a red tape, or just write it in red, or just write it down that it's an A2L refrigerant. Just document on the tank. Again, have a 10-foot radius work area. That's recommended at the time. Obviously, never vent refrigerant. Pull a vacuum on a new recovery tank, always and forever. Even if it comes with nitrogen, we want to pull that down to 500 microns or less to make sure we're down to no moisture inside there. Use only A2L recovery cylinders when you can. A2L tools should be rated for A2Ls, and I'll get a little bit more into that. They're asking you to use a liquid line filter dryer, or I am asking you to use a liquid line filter dryer to protect your recovery machine, only because of my experience. When I first started out in the industry, I blew through a couple different recovery machines thinking they were junk, and it wasn't until a rep of that vacuum pump actually shared that with me, and you probably already know that. But protect that motor just like we do with compressors. Be sure to use valve core removal tools. If you were to look at a chart and see, it doesn't matter how big your CFM's on your recovery machine, if you're not removing the valve cores or using large recovery hoses, you're still at the equivalence of about 1 CFM vacuum pump. Seriously. Recover all refrigerant before opening the system. Do not exceed the cylinder fill weight. Obviously, still the standard is going to be 80% liquid. We allow for expansion. And then label the recovery cylinder contents if you don't have that red stripe. You're still going to see tara weight, the weight of the tank, water capacity, what it would weigh if it was water, and then you're going to have a date. If you don't know that date on there, you add 5 years. If you add 5 years to it, that's the expiration date. If you didn't know that, a lot of people don't know that. Okay. Always follow manufacturer's literature. Use inert gas to remove any residual refrigerant of existing line. Ensure equipment is grounded. Use proper capacity discharge method. Use only OEM approved A2L replacement parts. That's important. Okay. Install a new liquid line filter dryer. Now, I'm putting that in there only because it's in there on AHRI safety and handling guidelines for A2L refrigerants. I personally have always used liquid line filter dryers even before we went to POE oil. It saved me a lot of headaches. It's the way I was taught by a couple old Germans at a Lennox dealer that I started out with 34 years ago, and it just stuck with me. It's if you've ever tore a liquid line filter dryer down and saw what it does, it saves you a lot of headaches. Use nitrogen before and during brazing. Recharge system by weighing in the charge. Document that information. As I said earlier, you're going to see a ton of stickers that you never saw before. It's going to look like a NASCAR now moving forward on A2L equipment. They're going to require you to document that place. Always leave installation manual with equipment. Nothing we really changed. I'm going to blow through this a little bit because it's literally the same as I was teaching at Emerson with A1s. Again, that 10-foot work radius. It's still a blend. All I literally did was change this tank to 454B from 410A. It's the same picture I've used for years. These systems typically come with, let's say for the sake of not arguing, let's say it came with 15 foot of charge. You would then weigh in that after the 15 foot of charge, whatever your line set is. And I'll show you what that calculation is for 454B. You'll then get your charge in as close as you can. Obviously, release the charge here, start it up, let it stabilize for 15 minutes, and then you'll go to the low side and start the charge. Now, we don't want to slug the compressor. we're putting it in with liquid, so we got to be careful. We throttle it or use our calibrated wrist, if you will. If you don't want to use your calibrated wrist, something I picked up years ago, about 8 years ago, and I take these along with me in class, or I used to when I was at Emerson, and I pass them around class. A lot of people don't know they're out there. I think this one was made by JB, but all manufacturers have them. You literally put this on your tank itself, okay, directly on the tank, and it acts as a metering device. But more importantly, what it really does is it dribbles in. If you're on a scale, so instead of throttling and seeing your gauges shoot up really fast and then have to shut it down and wait for it to stabilize and find out that you overcharged it or shot over, this thing trickles in like 1 Mississippi, 2 Mississippi, 3 Mississippi, very slow, and it vaporizes it, like I said, atomizes it. So any liquid that does get through is flashed off by the heated compression. It's a very, very good tool. It's very reasonable. I just want to share that with you. Airflow is the most important thing, in my opinion. I could talk for hours on airflow alone. If the airflow is not right, nothing else matters. You will need this adapter moving forward for these tanks, and I'll get a little bit more into that later. Use calibrated gauges. What I mean by that, a lot of folks don't know how to calibrate gauges. So I was on a job site working on a piece of equipment. I'll give you an example years ago that actually happened to me. I always carried 2 and sometimes 3 sets of gauges. And supermarket people have more than that. Actually, they change gauges when they change the refrigerants and what have you, from refrigeration to air conditioning. But I was checking the system out, and all the numbers looked really good. Everything looked good, but my pressures were off. So I was really confused by that. So I went to the truck and grabbed my other set for pressures, and it read correctly. So I was trying to figure out which one was right. So to calibrate gauges, whether they're compound gauges, digital gauges, whatever gauges they are, we need saturation. Saturation, by definition, is liquid and vapor in combination with each other. As long as we have 1 drop of liquid inside of anything, that's saturation, okay? You find it in our coils, evaporator and condenser. We also find it in receivers, and you can also find it in a tank of refrigerant. So you simply go to your truck or right there when you're working your working area and hook directly up to the tank itself and set the refrigerant gauges to the refrigerant you're testing. Take a temperature reading of what's outside, and you should be spot on your PT chart. I did this for years with recovery tanks. I could tell right away if someone was lying to me about that was only 410A in there. It will show it right away. Now, don't do this on a rooftop unit with 120 degrees or -10 like it is in Ohio, but 70, 80 degrees, somewhere thereabouts, in a perfect world, you'll get almost exactly. So that's how you calibrate your gauges. If you're using now on 410A, if you have a 3/4 inch line to 3/8 liquid line, we're using the calculation of 410A of 0.60 ounces per foot. Moving forward, if you care to know, in the same application on that particular line set size, 3/4 and 3/8, you'll use 0.55 ounces per foot. So the density is different, and you'll see that in the tank weight also. On the old tanks, you'll see 25 pounds. On 454B, it'll be 20 pounds. And they're not shorting you any refrigerant. It's the density. It's just like that water capacity weight that we have on recovery tanks. A gallon of water doesn't weigh what a gallon of milk does. Okay, so it's all about the density, all right? So you'll see that moving forward. They're not putting more air in your bag of chips. It's just the density of the refrigerant, okay? So you're going to see this sticker. Like I said, there's going to be lots of stickers moving forward required by UL. And you're going to see this chart. And it's going to require you to check this chart to make sure you have the right square footage per the pounds that's in that system, okay? So for example, we got a 3,500 square foot home. Let's say, for the sake of not arguing, we got a 5-ton system. That 5-ton system has 11 pounds of charge in it. For an 11-pound charge system on a split system, ducted system, you would need a 163 square foot home, not room, the whole home. Because the thinking behind this is if you were to have a leak by the evaporator, the detector would go off and then the blower goes off. That's part of the safety features, okay? So don't get confused by this. A lot of people are getting this confused as the room size. So I don't want a bunch of people out there putting transition grills in. It's a 163 square foot home. This is exactly what you're going to see in either on the evaporator or on the air handler inside the equipment, okay, or maybe on the outside door. I can't speak for all OEMs, but it is required by UL to have this in there, in the manual and a decal out there, so you can do quick math and not have to try to pick the formula up itself. So the reason I'm showing you this is I'm not trying to play this down, but literally you saw how close the flame resembled to what we were already using. This is about what 163 square foot looks like, a home. And I've done a lot of undergrounds. I've done a lot of crawl spaces. I've done a lot of new homes with basements. I mean, a small home, track home for me back in the day when I was much younger with maybe, 1,500 square foot. So 163 square foot home is not really realistic. But just so you know, now when it comes to mini splits, I do want to point out to you that is a different chart, and that is based on room because you have the opportunity to shut that door. So that leak is just in that room. So that's a different animal, and we'll have a different chart in it. As far as service trucks, it's pretty much business as usual under the materials of trades. So the DOT kept it the way it was before. If you didn't know, we've always had 440 pounds maximum in our refrigerant tanks or any tanks, no matter what the hazard is. So that could be acetylene. That could be something highly more flammable than A2L refrigerants, okay? And the 440 pounds isn't just the refrigerant weight, it's the tank itself and any container it came in, boxes or whatever, okay? So they didn't lower that. That's a good sign. You would think if it was highly flammable or more dangerous that they went to 400 or 350 or even 300. They did not. That stayed the same. Federally, there are no placards required for service vehicles. And ventilation, there is no ventilation required for the service vehicles. A2L tanks will be able to lay horizontally, okay, as long as they've applied for a special permit from the DOT. Chemours did this test about 3 years ago because the DOT was requiring it. So Chemours alone went and did all the testing for the industry. True story, way before I got here, by the way. So I can't take credit for it, but Chemours did all the testing. And when they did the testing, it passed. And I'll explain to you later on what they were trying to test for. Well, basically it had to do with the rupture disc on the tank, where if it gets too hot in the van, it explodes. Ruptured disc will blow the whole charge. So they were worried about if you laid it horizontally, they wanted it up vertically. Because again, you don't know what you don't know, just like they didn't know about equipment, the sell-through date. They wanted a vapor barrier with it being upright up against that, in between that ruptured disc and the liquid in the refrigerant. And in reality, good practice has always been to put the rupture disc at the 12 o'clock position in your truck, even though in Ohio, I've never seen one of these blow. But if you get in Arizona, Southern Florida, even Mississippi, Alabama, where I teach a lot at, you do see these things happening, but very, very seldom. So that was the fear of it. But now anyone, our competitors, any OEM, Trane, whoever, Mitsubishi, they can all apply for this permit number, basically, as long as it's stamped on the tank and it has a QR code. In fact, I just did a video yesterday that's going to be released soon talking about this specifically. So just so you know, if you hear anything else, that's not true. As long as they apply for the permit number that we've already established, it's the same permit number that we got approved for. Everyone, once we did it for the industry because each person does not have to do the testing anymore. A2L tanks moving forward, they're going to have left-hand threads. You're going to have a red band around them. For years and years and years, I was traveling around with two tanks. One was the red top, completely red. One was with the red stripe. They finally made a decision. When they did make that decision of a red band around it, they decided to go with left-hand threads. I kind of like this now. I didn't at the first because I thought it was a money grab, and I thought to myself, well, heck, we're technicians. We can bypass anything. We'll figure out a tool or somebody will make something to get around that problem. But I like it now, especially having like a son in the industry and as many young people as I see in the classroom when I teach. There's a lot of people starting their very first day today, thousands and thousands of them nationwide. And there's a lot of them, as you know, in our trade, it's pretty standard to move from preventive maintenance to service overnight simply because it's 90 degrees outside and we're 50 calls behind. I live that world, you live that world, it's reality. So I like this now because if Susie or Sam comes up on their first day, tries to put their hoses on this A2L and they don't know, my hope is they'll call the wholesaler or you, the service manager, or a friend and just say, hey, don't get me fired, but I'm having trouble getting my hoses on this tank. Does it have a red stripe around it? Yes, it does. Stop what you're doing. So I do kind of like it now. Think of it as a pause button or a safety net, if you will. And by the way, all you're doing here is putting this adapter and making it right-hand threads. The long and short of this, the story behind this is manufacturers of equipment and tools did not want to go to left-hand threads. It was too costly in the factories. They're going to still be making right-hand threads for other things that are still out there and will be out there forever. So they didn't want to keep changing dies. So they stayed the same, and the least path of resistance was to make this little adapter to connect the dots, if you will. They're not that expensive. I would buy two because when I first saw it, I had haunting memories of my little adapter for my mini splits that I lost in my truck all the time and would find 2 or 3 of them by the wheel well after I would clean my truck out. So get two. They literally go right on the tank. If it was me, I would put it on the tank and leave it on there. It has a Schrader that you can either remove or keep in depending on you. You just hook your hoses right up to it. But once it's on the tank, you know that's A2L refrigerants. Okay. Again, it will have a different safety device moving forward. Unlike the ruptured disc for existing refrigerants we use, the way this works is a lot of people throw the temperature 125 or 130 degrees. That's always been used for storage temperature. Nothing over 130 degrees in the warehouse and what have you. And it's not really by temperature, it's more by pressure because each one of these refrigerants in a different tank is going to have a different pressure temperature relationship. So if it does hit that, whatever that danger pressure is, the way this works in the past is this rupture disc will blowing the charge, keeping anything from catastrophic happen, turning this into a giant hand grenade, if you will. And that's the moral of the story. When we empty these tanks, we're supposed to recover what little's in there, and then we decommission the tank by puncturing a hole in it or removing this completely to take it out of commission so no one gets hurt down the road. Moving forward, you're going to have a different type of safety device, only because it's an A2L refrigerant. By the way, this was not required. A lot of these things that you see added were not required. It's all about liability. We're talking about billion-dollar companies here. That we live in a sue-happy world right now, unfortunately. So they actually put this safety device on there, not required. And the way this works is, unlike a ruptured disc, it's a spring-loaded relief valve, okay? And the way it works is, if it should hit this danger zone in the south or someplace extremely hot, okay, it will burp, if you will. It'll release just enough refrigerant to take it out of the pressure, which will lower the temperature and lower the pressure and allow for that expansion. And moving forward, that's the way it's going to go. Again, it was not required, but for fear of it leaking in the truck, for the fear mongering that was going on back in the day with A2Ls compared to propane, they decided just to go with this. And by the way, these are already on and have been for a long time on larger tanks. So they're already been used, okay? The problem here is, if it is a problem, this is solid steel. You will not be able to puncture a hole in it. So moving forward, good practice is going to be puncture a hole in the side of it once you've removed the refrigerant. Okay, circle it where the hole is and then write empty on the side of the tank. Again, who's going to police this? I don't know, but now you know what's going to be asked of you required moving forward. A2L tools. I used to go through all the A2L tools. Basically, I'm going to put this in a nutshell for you. The more tools I added, it started looking like a NASCAR slide. So I have no skin in the game here, no dog in the fight of what tools you buy. I will say this, for the last 2.5, almost 3 years now, they've been selling A2L tools. Does that mean the tools in your truck are not A2L qualified? No. In fact, most cases, I have not heard differently. They will work, okay? Some manufacturers have openly told me that I've actually done training with 2 hours and 2 hours, shared the stage with, are telling them that some of them are the same equipment. They've just tested them by UL standards for the A2L equipment, and they passed. In other words, they put the recover machine in a plexiglass box, if you will, and put the right amounts of concentration of 454B in there, and they tried to hit the switch or light it, and it didn't light. Now, they did say, if you, for example, if you remove that switch, or if you bypass the switch and you don't use an OEM part, then all bets are off, okay? Not everybody didn't change things. Some people did moving forward just because of liability, but it doesn't mean what you have in there does not work, okay? Um, again, some of the things you're going to see and tools moving forward, again, some of them are staying the same. Here's what I've been telling everybody because it's much easier. Either go to your wholesaler where you bought the tool from, or it's real easy to go to the tool manufacturer's website. They're all doing a really, really good job of having an A2L tool button on there. When you hit that button, what I've seen on the few that I've checked out is a drop down, and it tells you the existing tools that are out there that are qualified. And I haven't seen anything yet that says that something does not work. If you hear something or see something, let me know. Okay. You might see moving forward, by the way, because of that 10-foot recommendation, you may see, I heard this third party, I haven't seen it in writing, so don't hold me to this. You may see some recovery machines in the future coming with a 10-foot extension adapter inside the box to possibly, if that 10-foot recommendation ever turns into a 10-foot required. Okay. Some of the things, obviously, the things we're really focused on are the electrical things, okay? The vacuum pumps, and not so much really a vacuum pump. Really, recovery machines is what interacts with refrigerant the most, okay? Gas detectors are still going to be the same. It's still got the same refrigerant in R32 and 1234YF, so you're going to pick it up. Electronic leak detectors, pretty much the same. But moving forward, again, do not buy anything that's not A2L rated, or compatible is the word they like to use right now on all the pamphlets, compatible. But check with your manufacturers, though. All right. I just don't want you to go out and buy, because I've heard horror stories from 3 years ago where people went out and retooled 15 vans and it was thousands of dollars that they didn't have to spend. Hand tools, obviously, that's kind of a no-brainer. Obviously, nothing's changing there. It more has to do with the electrical stuff, the wiring or the switches. It's really the contact. And you'll see that on the equipment moving forward, too. If you see a defrost board where it used to be metal to metal on the spade, you're going to see a lot of rubber coatings and things like that, case contactors and what have you. Those kind of things are the changes you're going to see in the new equipment. Equipment examples. This is very high level. One size does not fit all. I'm just going to show you what UL required. UL required that the detector on the evaporator coil, which will be in all air conditioning equipment, required to go off 25%, no more than 25% LFL. LFL is lower flame limit. Until it hits LFL, it's not even flammable. So there's an upper flame limit and a lower flame limit. In other words, it has to be in that upper and lower to have the right amount of concentration of air and chemical or refrigerant in this case to even ignite. So it's going off way below the LFL. All right. And in most cases, I have not seen this differently. Depending on the OEM, it's going off at less than 25. The highest I've seen is 20% or greater. It goes off. Some of them are as far as 12%. Okay. So it depends on the manufacturer. So this is one size does not fit all. Just know this, the detector will go off. The unit shuts down outside, activates the blower or energizes G as we know it as the fan. Okay. It runs for 10 minutes, 8 minutes, 5 minutes, whatever the OEM decided. Okay. That's not sketched in stone from the UL. I think it was a minimum of it had to be 10 minutes. Detection, again, once it detects less than 20%, 12%, whatever the OEM decided that detector was going to go off, it then goes into a blower continues for 5 more minutes, and then it resumes normal operation. Not all this is identical for every OEM. So whether you're buying brand X or brand Y, check with the manufacturers because they're all slightly different. But UL set the standard for the minimum it could be on that kind of thing. Okay. Again, all these decals, you're going to document how much refrigerant you added, okay, per the pounds. So that weight addition that we talked about on the line set, all kinds of new decals letting you know you're handling something differently. Moving forward, when the equipment comes to you, it'll have a red cap on it. You also notice nothing to, well, kind of to do with A2Ls. You'll see this long extensions on the OEM equipment. I have not worked with any of the OEMs, and I've worked with all of them except Daikin that are not doing this. They're extending these service ports out, removing the bell fitting on the end. So it's a male straight pipe. This is for the new movement that everybody's going to compressed fittings, where they don't have to get their nitrogen out and do any brazing. They can just start right off the bat and do compressed fittings all the way. My son loves that stuff. Okay, that's going to be on the indoor and the outdoor system. Okay, the red caps. Once you remove this red cap, you're going to be asked to put some type of cap on it. And under the IMC, they require locking caps on those too. So I know there's a big push to get red caps out there, but just know this: when it comes to the factory, it'll have a red cap on there on the indicator. You can obviously see this is a heat pump. I'm at the end now. Some of the resources for us, go to our website, www.option.com training. You'll see all kinds of good stuff. We're really building it up. We have a monthly webinar that I do. It's called the Chill Zone, Condensing the Facts with Don Gillis. It's an hour long. I just did one yesterday. It's the first Tuesday of every month. You also see Dr. Chuck Allgood. These are about 4 to 6 minutes of kind of things like, did you know, fun facts. You can do these in between service calls. And I think he's in his 6th year, if I'm not mistaken. Data sheets, pressure temperature charts, refrigerant replacement guide, what replaces the refrigerant that's in there for retrofits, tech tips, tech support, all kinds of stuff. Everything is free here. This has changed a lot since I've been here. It's really amazing how much it's changed. We're really focused on, we don't have enough boots on the ground. There's not enough me's, there's not enough salespeople, there's not enough marketing people. I'm the only full-time technically trainer for Chemours globally in the U.S. So they lean on me pretty heavy because of my contractor experience in the field. So I work primarily with engineers, but all kinds of good stuff there. All right. If you need to get a hold of me, email me at don.gillis@chemours.com. This does qualify for 2 NATE hours. If you're not NATE certified, you can still get this certificate if it ever comes into play. Again, the EPA is not requiring you to be certified for A2Ls, but maybe a municipality or a wholesaler or a refrigerant manufacturer is asking you to do it. We have helped everybody. I myself and another marketing person, since I came on board, have helped everybody in the industry with their testing. The folks that charge for it, like ACA, ESCO, all of them. We've had a part to play in it. We've proofread almost everything that's out there for them. Why? Because we're the manufacturer of the refrigerant. So the reason I'm telling you that is I feel that our certificate holds a lot of weight because we are the manufacturer of the refrigerant.